This revision video links forces, acceleration and Newton's law. Newton's laws, there's three of them. The first law is that unless there is a resultant force, the object stays stationary or in motion. So stationary or constant motion unless there's a resultant force. Now we're going to give some examples of this, starting off simply and getting more advanced. So we start off with a stationary box, 10 newtons forwards, 10 newtons backwards, resultant force is 0 newtons, so that box stays stationary. In this example we've got 15 newtons forwards, 10 newtons backwards, we've got a resultant force of 5 newtons forwards, so the box will accelerate forwards, it will start to move forwards. For moving objects, it's a little bit more complex. So I've represented this scooter moving with these little lines here. Got a forwards force of 100 newtons, a backwards force of 100 newtons, therefore we've got a resultant force of 0. But this scooter's already moving, so it's just going to move at constant velocity or constant speed. This scooter, however, has got a forwards force of 150 newtons, a force in the backwards direction of 100 newtons, therefore there's a resultant force of 50 newtons forwards. This scooter is going to accelerate forwards because there's a resultant force forwards. It's going to accelerate forwards, it's going to get faster. If you look at the other way around, if you've got 150 newtons force backwards, 100 newtons force forwards on a moving object, 100 take away 150 is minus 50 newtons. That minus 50 means it's negative, so it's negative acceleration, which is also called deceleration. Another way of looking at it though is 150 take away 100 newtons, we've got 50 newtons backwards. If the resultant force is backwards, we're going to get deceleration. So that is Newton's first law. An object stays stationary or constant motion unless there's a resultant force. Newton's second law is that force, mass and acceleration are linked. They're linked by this equation, and acceleration is proportional to the force, which means if the force is increased, the acceleration increases. And acceleration is inversely proportional to mass, so if the mass increases, the acceleration decreases. And let's explain that inversely proportional relationship with examples of two vehicles. We've got two vehicles here. One vehicle weighing 1,000 kilos and the other vehicle weighing 500 kilos. Force of 500 newtons is applied to both of them, so it's equal. The acceleration is unknown. We put the numbers into the equation, so 500 newtons equals 1,000 times acceleration. 500 newtons equals 500 times acceleration. We can then rearrange these equations. The opposite of times by 1,000 divided by 1,000. The opposite of times by 500 divided by 500. So 500 divided by 1,000 gives our acceleration of 0.5 meters per second squared. In this instance, 500 divided by 500 is our acceleration of 1 meters per second squared. So for a lower mass vehicle with the same force, we get a bigger acceleration, which is logical. Newton's third law is that every force has an equal and opposite reaction force. So if a wheel is pushing backwards on a road by friction of a force magnitude of 200 newtons, the road must push forwards with 200 newtons. Another example of this is a person in a boat. If the person jumps off the boat in a forwards direction with 75 newtons, the boat must move backwards with a force of 75 newtons. And this final bit is for higher tier only. Higher tier only, you need to know that inertia is the tendency of an object to want to continue in its line of motion unless a force is applied on it. You also need to know what inertial mass is. Inertial mass is how hard it is to get something to accelerate. But what does inertial mass mean? Well, it basically just means what is this mass in this equation. So we rearrange it. The opposite of times by acceleration is divide. So force divided by acceleration is mass, and that is what inertial mass is. Inertial mass is the ratio to acceleration.